Okay, please listen carefully. If you were to take 85 milliliters of a 2.56 molar solution, so you literally take 85 milliliters, you put them into a container. You then take and mix that 85 milliliters with another 325 milliliters of water. What will be the new solution's molarity? So, a couple of hints. One, find the moles first. Then, find the new molarity. But remember, if you're going to mix these two solutions together, this 85 and this 325, think about what that does to the volume of the new solution. You are literally mixing them together. That formula will be used twice. First time, solve for moles. Second time, solve for molarity. Go to work, ladies and gentlemen. I will get attendance. If you have questions, you can then let me know and I will give you some assistance. So if the problem stopped at the first comma, find the moles. Okay? If the problem stopped at the first comma, find the moles. That's the first thing you need to do. Bless you. Bless you. Bless you. Wow, apparently sneezes are contagious this morning. Don't worry about that. But you don't need that for this one. You don't need any formula mass for this one because I never gave you a formula. Okay? The water is what's it's dissolved in. The water is not the solid that gets dissolved. I never told you what the solid was. So from those first two things,
you need to calculate the number of moles. But you didn't convert this into what? So that's going to change that number. Then take that number, that moles, and you can use it in the formula to find the molarity of the second solution. Okay? Before you convert it to moles. The moles come from the 85 milliliters of the 2.56 molar solution. So find that mess.
By the way, on this problem, I didn't tell you what the solute was, what was being dissolved, because it doesn't matter. You do not need formula mass for this problem. You need to find the number of moles that are in 85 milliliters of 2.56 molar solution. That's the first thing you need to find. Yes?
And it says the mix was mixed with 325, so do I do it again?
You put that amount of moles into a new solution, yes, that contains a certain volume of water.
Oh, 325.
Well, read the whole thing and then tell me what you think. Remember, you take this 85 milliliters out, you put it over here. You then take 325 milliliters of water and add it to that. And now you want to find the molarity of that new solution. Molarity is found by taking moles divided by liters of solution. That's how we find molarity, is taking moles divided by liters, correct? Okay, ladies and gentlemen, let's see how you did. All right. So imagine, ladies and gentlemen, that this is our 2.56 molar solution. Okay? That's what this solution is. We're going to take 85 milliliters of it. Then you put it into another container. Now, in that container right now, I not only have 85 milliliters, but I have a certain number of what? I have a certain number of moles. It is a portion of what was in here. Okay? So our first step is to figure out how many moles are in that container. Okay? So to do that, ladies and gentlemen, we've got a molarity and we've got a volume. We've got this number and we've got this number. You can find this number. Okay? Now I am going to choose to do this problem using molarity as a conversion factor like I showed you the other day. Meaning I am going to look at 2.56 this way. 2.56 moles equals 1 liter. Okay? I never told you what it is a solution of. That does not matter at all for this because we weren't given grams that we need to convert. So we are going to take our 85.0 milliliters, and the first thing we have to do is what? Make it into liters. Okay? The next thing I'm going to do is make a conversion factor out of this up here. So to do that, I'm going to put 1 liter on the bottom. I'm going to put the 2.56 moles on top. Liters and liters cancel out. All right, did anybody get an answer for this? This part you should have been able to get done, ladies and gentlemen. Come on, someone give me the answer for it.
0.2176.
Perfect. Now, again, this is not a final answer. You've got more sig figs than you need. How many sig figs are going to be in your final answer? 3. You've got more than you need, but that's fine. So now, ladies and gentlemen, now what we want to do is now we want to find a molarity. Well, molarity equals moles divided by liters. I've got the moles, 0.2176. What I need is the volume. What you have to understand is this. Here is the 85 milliliters, right? Now I am going to add 325 milliliters of water to that. What do I use for my volume? How much is in there? It's not 325, is it?
410 milliliters.
What?
410 milliliters.
It is the 85 plus the additional 325. That was the only tricky, well, that was the tricky part to this problem. Is that when I mix these together, the total volume now becomes these two numbers added together because I can't put this in there without putting the water in with it. So you're adding these two volumes together, ladies and gentlemen. And if you add 325 and 85, we get 410 milliliters. Not worried about sig figs at all. Okay, not worried about them. But when I come down here, I better put that into liters. I better put it into liters. Now, ladies and gentlemen, you can find the molarity. Denia, what is it?
0.531.
0.53 what?
1.
Perfect. 0.531 molar. Questions? Yes, no, maybe so. Now, I will tell you, I will not give you a problem like this on your quiz on Friday. Okay? Some of you can now breathe. Okay? But this is how you can use molarities. This is what we do as scientists. I take an acid that is very concentrated and I add water to it to make it less concentrated, and I need to figure out what the new molarity is. Okay? That happens all the time. But also, if you take two aqueous solutions, that means they are both dissolved in what? Water. And if I combine 50 milliliters of one solution and 50 milliliters of the other, and I literally put them in the same container, how many milliliters of solution do I have now? Elsa? 100. 100. So you have to understand that sometimes when you mix things together, you have to add them together, because if they're both liquid solutions, in the end you end up with a larger amount of water by putting those two waters together. And that is what all of our solutions are going to be dissolved in. So when we talk about something being aqueous, that means it's dissolved in water. Water is not the solute. Water is not, you don't need to figure out the formula mass of water. Why? Because water is just the place where these things are happening. Water gives us the volume that we get. And remember, in all of these, there's no using 22.4 because these are not gases. These are liquids that we're mixing together. Liquid solutions that we're mixing together. Questions? All right, take and open your EISN up, ladies and gentlemen, and get to slide number... let me check here. All right, so this is the problem we finished yesterday, correct? Did we get through this one? Okay. All right, so here's what I want you to do. Take out your packet that I gave you the other day. This one. Okay? Take out this one. Okay. Take 3 minutes, ladies and gentlemen. Read through the first question and write a balanced chemical equation for the first question. Okay? Take 3 minutes, read the first question, write a balanced chemical equation for the first question. Now, we can't do all of these on here yet, ladies and gentlemen. We will get to the point where we can. But right now, these problems start out with you being able to read this equation and write a balanced chemical reaction for it. Okay? And this is literally telling you what the reactants are, and it is also telling you what the products are. So let's try to write a balanced chemical equation for it. So if 20 grams of magnesium reacts with hydrochloric acid, how many grams of magnesium chloride are produced? Hydrogen gas is the other product. You have two things before the arrow, you have two things after the arrow. When you get all of your formulas written in the right spots, then you need to balance it. You don't need to worry about putting any amounts or anything in, just write a balanced chemical equation for these things reacting. Magnesium, metal, and hydrochloric acid.
Diatomic, so how do we write it? Put that 2 by. Now, put states of matter in there.
You should be able to put states of matter in for everything. The only thing that I didn't tell you was magnesium chloride, but in this type of reaction, the compound on the product side will be aqueous.
This one's gonna be just a metal. That one there, that'll be aqueous. Okay? Because that's a low, it's just magnesium metal. Okay? This, no, you can't, but this is not a diatomic. Get rid of that number. We don't need that there. That will make a big difference, that will get a balance. Yes. Yep. That is not hydrochloric acid. Okay, something wrong with your H on the product side. Check your compound magnesium chloride. It's not hydrochloric. That is chloric acid. Hydrochloric. Ionic acid name starts with hydro, ends with ic. Means it's between hydrogen and one other nonmetal. Okay. That is not, well, that's not hydrochloric. And that's not magnesium chloride. Oh. Hydrochloric acid. Name starts with hydro, ends with ic. That means it's this kind of acid. Okay. But you forgot something about this one here. Something that you have listed. Yeah, right beside there. Nothing's wrong with this. Something that you should have written on your periodic table that's special about that element. Again, this one. Yes, but this is not, this is a gas. Okay? Check that formula. Check that formula.
Okay, coming around looking at you. Most of you have the general gist of it. You got to be careful. Again, we're going back and we're naming acids. We haven't done that in a long time. I didn't give you that blue sheet so that it could sit in your folder forever and you never use it. Okay, that blue sheet will help you write compounds. Now, again, a lot of you did well. What is the one thing that most of you that I came by you missed? The diatomic. You have to recognize those 7 diatomics because they are created quite often in reactions and released as gases, especially hydrogen, because when you're working with acids and you put them with any metal, they are going to release hydrogen gas. Well, you got to put that down as H2. You have to put that down as H2, okay? So let's take a look at this, ladies and gentlemen, because again, most of you did a pretty good job with this, okay? Now, I am going to ask a favor of you. Man, you got to write so that I can read things on a test. Some of you, I mean, your compounds were that big, and I'm like, okay, is there a 2 there? Is that a G there? Is there a what? You know, you got to give me something that I can read for sure. All right, Denia, give me the reactants in this reaction as you have them written, just up to the arrow.
Mg plus HCl.
Okay, Denia, what states?
Magnesium is a metal, and hydrogen or an acid is AQ.
Good. Now, I do not care which one you write first and which one you write second. As long as these are the 2 things that are on the reactant side and they are written the way they are now, you will get points. By the way, on a test, each one of these formulas gets you a point. So right now you got 2 points earned on the test. Okay? Now we say that there is going to be a reaction, which means there is going to be an arrow. And now we need to write the 2 products. Now, the one thing I do on the test is after I give you this statement, I will in one sentence tell you this and this are the reactants, this and this are the products. So it's a little bit easier for you to find. Now, I don't give you their formulas, but I do give you their names. So the names of your 2 products are magnesium chloride here and hydrogen gas. Natalie, how would I write magnesium chloride and how would I write hydrogen gas?
H2 plus MgCl3.
I will agree with everything except the AQ by H. Read in parentheses. Hydrogen. So what should be by H? Nope. A G. Gas. Gas. Okay. What should be by the MgCl2? No. Aqueous. The only thing you will ever put M by, ladies and gentlemen, is metals. That is the only thing you would ever put M by. MgCl is a compound. It is no longer a metal. Metals are the elements on the periodic table when they are alone. Okay? When they are alone. Now again, I will give you things like magnesium metal reacts with aqueous, hydrochloric acid. Now, I shouldn't have to tell you an acid is aqueous. We know that. But I will tell you that it produces aqueous magnesium chloride and hydrogen gas so that you can get the states. Right now, ladies and gentlemen, this would be worth 4 points for the formulas. 1 point for the states. And now, what do we need to do to this? Balance it. Who could tell me how to balance it? What do I need to do to have this balanced? Put what where? A 2 in front of the HCl. There is 1 magnesium here. There is 1 over here. We now have 2 hydrogens here to go with the 2 hydrogens here. There are 2 chlorines here. Well, we have 2 chlorines because of the 2 in front. Okay? By the way, we didn't mention it. HCl. H is a +1, Cl is a -1. So that is why it is HCl. Magnesium is a +2. Chlorine is still a -1 when we do the crisscross method. That is how we get the MgCl2. You always need to write a good compound. If you are sitting there trying to balance your chemical equation, and no matter what you do, you can't get it to balance, you're like up to putting 5s and 6s and 7s in there. Stop. Go back and recheck each one of your formulas. If you do not write this formula correctly as MgCl2, you will never get this to balance. Never. There are no numbers you can put in. It will not happen. Okay? Now, that doesn't mean that if you write a wrong formula, you might still get it to balance and the formula might be wrong. But if you can't get it to balance, I will guarantee you, you have a formula written incorrectly. Okay? Now, you got to do 4 of these on the test. So there's going to be practice in this worksheet for you to do. But again, how much practice you do is going to determine how quick you are on this, which means that's how much time you get left for the rest of your problems. Okay? So take 71 minutes divided by 4. You're talking about having to do these in about 15 minutes apiece. Okay? Start to finish, 15 minutes for one of these problems. Okay? All right. Now, the next thing that I would do with this problem, ladies and gentlemen, is I would write down what I'm given and I would write down what I'm looking for. I'm given 20 grams of magnesium. So I'm going to put 20.0 grams by the magnesium. I'm asked to find how many grams of magnesium chloride. So under magnesium chloride, I'm going to put a question mark and then G. Now, that doesn't mean that my answer is going to start out in G, but it means my final answer has to be in grams. So this is a mass-to-mass stoich like we did yesterday. Questions? So now we are down to 3 steps. Step number 1, take what you're given, get it into moles. Step number 2, use a molar ratio. And step number 3, report out in your final unit. That is what we are down to. 3 steps. So let's do step 1. Take what we're given, and what we're given is the 20 grams. We're given the amount of magnesium. So I'm going to take those 20 grams of magnesium, and I'm going to convert them into moles. How do I go from grams to moles? Formula mass. 1 mole on top, formula mass on the bottom, 24.305 grams, correct? Madison, can you wait until we're done with this and then go when I give you work time? Okay, thank you. Because I don't want you to miss this. In a minute, you'll have work time. You can go then. All right. So now, ladies and gentlemen, now becomes the step that we are not used to. Now becomes our new step. And our new step is the ratio step. We have taken what we've been given, and we have gotten it into moles. The next step is to go from moles of one thing to moles of another. Now, what we're going to and from, ladies and gentlemen, is we are going from magnesium here to magnesium chloride. That is where we are beginning, and that is where we are ending this problem. So our fraction here has the one that we are in on the bottom. So mole of magnesium. Now, the number that comes in front of the mole comes from the number, the coefficient in the balanced chemical equation. Now, there is no number there, so what does that mean? That means 1. That means 1. We are going to moles of magnesium chloride. Again, ladies and gentlemen, the number that I put in front here comes from the balanced equation here, which also happens to be a 1. Okay? What this is going to allow me to do is get out of moles of magnesium and into moles of magnesium chloride. Okay? Now, I want to clarify something here. Yesterday, one of my class asked me, well, Mr. Brand, if there was a 2 in front of here, would I put a 2 here? No. This is the step we learned in Unit 5. This is going from moles to mass, or mass to moles. This is always 1 mole on top. This is always formula mass on the bottom. Any numbers that are in front here will be taken care of in this ratio step. Okay? So you don't have to double something over here because there's a 2 in front, or triple something because there's a 3 in front. That will all get taken care of right here in this one step. Questions?
Good morning, Susan Beth. I am sorry for the interruption. We are going to have to go into a lockdown outside situation. This has to do with police activity in the area. We will be able to continue our day with students going from class to class or going where they need to, but we will not be letting people in and out right now. So we will be going, I will be using, the lights will go on, you will hear an announcement of a lockdown outside situation, and as soon as it is resolved, we will take us off that lockdown. Thank you for understanding, and have a good morning.
Okay. So just so you know where we are at. 1, given into moles. That is this part right here. Wow. That better not keep going off.
High school.
Yeah.
Building outside situations. Attention, staff, and students. We are now in the secure the building outside situation protocol. Bring all staff and students inside the building. Outside doors remain locked. No one is to enter or leave the building without police or administrator approval. Continue
So,
the normal schedule within the building. All
Step
activities
1,
are canceled.
take what you're given and get it into moles.
Staff and students
We're clear, right?
are now in the secure the building outside
Step number
situation
2, molar ratio. Given on the bottom, going to on top. That is what your ratio will always be. Whichever one you are going to goes on top, whichever one you are given goes on the bottom. Okay? So I should probably get rid of this given on. What you are given goes on the bottom, what you are going to goes on the top. Questions? All right. Now, the last step is to report out in your final unit. What final unit does it want? Grams. So we are going to take, ladies and gentlemen, and we are going to multiply this by what? Formula mass. But it is now the formula mass of magnesium chloride. It's the formula mass of magnesium chloride. Okay? So, 1 mole of magnesium chloride on the bottom. Formula mass, which I believe is 105.988. Am I right on that? No, I'm not. I'm not. It's 95 point something. What is it? Okay. And now, ladies and gentlemen, you are going to be in your final answer, which is going to be in grams. How many sig figs? Okay. So I need someone to take their calculator. 20 times 95.205 divided by 24.305. Third step. Report out in final unit. Someone give me the mass that we would get. 78.3 grams. Questions? Okay, ladies and gentlemen. You cannot do problems 2 and 3. We just haven't gotten to that yet. Okay, if you want to look at them, you can. Here's the one thing you could do in problems 2 and 3. You could write a balanced chemical equation. If you want more practice and to get ahead, you could start writing balanced chemical equations for problem 2 and 3. But after that, you would have to wait. You can, however, do problems 4, 5, and 6. Okay? You can also do problem number 10. Although you can't do the percent yield part of that. So, you've got about a little under 30 minutes left to the hour. 10 minutes apiece, you could get 4, 5, and 6 done. You have questions? More than happy to help you. You want to go back and work at a lab table with a group of 2, 3, 4, 12 people? I don't care. Do it. You want to pull a couple desks together and work with somebody? I'm fine with that. But what you need to do is you need to start practicing. And again, go as far as you can, and if you get stuck, call me over. But this is your example, ladies and gentlemen. Write a balanced chemical equation. Take what you're given, get it into moles, molar ratio. You're going to report out in mass in all of these. Go to work, ladies and gentlemen. Even though it's at the start. So that is and again, it's all this it tells you hydrogen chloride is produced. So where is that? After zero. Then it tells you sodium chloride reacts sulfuric acid. So where do those react? Now it tells you it's a zone replacement reaction. React. One of the products is that it has to be one more product. So that's where the complex reactants. Complex products. Oh, sodium chloride.
accuracy of your test. So write those down on the left-hand side. Yeah, then the 300 goes all the way to the other side. By the way, ladies and gentlemen, in a question where it says the metal is acting like a +2, I'm telling you that because if you go to the periodic table and look up copper, you will not know its charge. Okay? So if that is the case, I have to tell you what its charge would be when it makes a compound. So it doesn't mean that there's two of them in one side, but I'm telling you, when you put it into the compound, and you're trying to balance off your charges, that's what the charge is. So if there's an element where you can't recognize its charge on the periodic table, it starts out low and then what charge it would be when you apply. No. Sulfuric is a ternary acid. Doesn't have hydro in front, it's ternary. Well, yes, 10 grams of sodium chloride are produced. Okay, so this is a simple replacement reaction. Chlorine has replaced what in its carbon. Well, all the things. This oxygen decompositions will take place. This has to be You can compare any two things in this one. Compare one reactor to another, you compare that. There it is. So that is the ratio set. The ratio set is what you're going to. Where you're going to press that. Okay. So that's going to work out. Thank you, man. Okay. What do you do? She was asking about a two in one. They were asking for two up to everything in one. Parentheses. For your ratio, efficiency. The ratio is what is from your balance of the That's the reason we got it. The ratio might be one, one, three, two, all different kinds of ratios. But we get it by taking the units in front of what we are going to over the number of what we are getting. Now here's the thing. This is correct. What we got. It's not this kind of thing. The plus two tells you the number of units. It's not there is a plus two charge to the units. That's all that's for. So,
This is.
right. With that alone, now it's just GCU, that would be what I have to tell you what a charge will be. Otherwise you can't know what that is. Not right. sulfuric is the same ending as hydrosulfuric. So sulfuric, look at your new sheet and tell me what it means. If the acid doesn't begin with hydro and it ends with the acid. But you're not reading it. Does your name start with hydro? Okay. Here you go. Let's go back to your head. Read home. Look backwards and friendly acid. Correct. Read the sentence. Read. What? What? Better put H in there if it's between H and something else. Okay. This one. This. Only reaction. This. Okay. So, yeah. Please. Almost. So I was really need to look at you can never reduce an acid if you put the target up. No, tell me. Okay, you can never reduce it. There might be a number by the hydrogen. But the other thing that it's with, you would only be putting the one by itself. In the crisscross method, they're not. There's something, listen, if there's a plus one here, where's that going to end up? By the other one, right? So do we ever write once? So you never have to worry about reducing an acid. You can always in most of. Yep. Still very good, still talking to you. Except for one thing, you don't have to. Can you reduce the acid? Can you change the sexual hormones? So that you can't reduce that. You don't ever have to worry about reducing acid. It cannot be reduced.
actually able to create because in double repeat doesn't have to be high enough in the period to clean.
This is the site for double replacement. But it's telling you that it's happening.
This so it doesn't matter. It doesn't matter anymore.
That site is not double replacement. This site is double replacement. We'll get into that later. Why do you look so disappointed?
Another thing is I think it was fine. And so yes.
That's what double replacement is. The things that are beginning more about the ones.
Yes. What?
right, ladies and gentlemen, I just want to let you know something. In the daily agenda today, there are a couple of more practice problems for molarity if you want them. I did not get to them today, but there are a couple of more problems for molarity that you can do if you want to do for practice for your quiz on Friday. So we have the problem on one slide. Where's it at? We have the answer on the next slide for you. We have another problem in the answer. We have another problem in the answer. There are 3 problems here that are similar to what you are going to see on your quiz on Friday. You can go into the Canvas page. You can go to the daily agenda and videos, and you can look up these other problems if you are so interested, ladies and gentlemen. You have plenty of opportunities to practice things. Also, tomorrow is a flex day. If you need me to flex you, or if you have questions, you need to let me know. Okay? Otherwise, ladies and gentlemen, tomorrow we will be moving on to the next type of stoichiometry, which involves volumes of gases. Okay? So that's what's coming. Have a very good day, ladies and gentlemen. Please don't let anybody in from outside since we're in a lockdown building outside situation. Just set it on my desk if you want, Katie. Candy. Thank you very much. Thank you. Thank you. Oop, that's all right. We're still there. You're the one who's always slowing Denia down. Why are you yelling at her to go? My goodness.